All right, yo, let's get it. It's the mic, not Discord, bro. There we go. All right. Excuse me. Wow, what the hell happened? Screen got turned down. Okay, doke. Some more class stuff. Last time we were dealing with constructors and multiple constructors. We're still on. Oh, we're on delegating constructors. So we were on this part where we could have like what? What would be a case where we'd what? Multiple. The manager example works. You could do character and maybe buffs that it spawns with. So we could have class. All right, let's start with int main. Actually, we don't necessarily need it. Class, character, and then we'll have private int health. Okay, and then we've got it's got health int damage. Sure, but then we might have maybe other things can have buffs, so we'll just say enum buffs or buffs. Okay, and then we'll have strength up, speed or agility up. And sure, we'll just leave it like that. And then this will have a buffs buff. And then we're gonna have a character constructor that takes, sorry, I forgot these need to be called member variables because they're data members. And this is going to be int health, int damage. In one case, and then here it says health is initialized with health and damage is initialized with damage. But then we have character something that takes a buff's buff. An M buff is assigned to be buff. Like this. Okay, and how does this look? Okay, that's fine. And then boom, that's it. And then we could have our getters. But we could have constructor for unbuffed character. And then we have constructor for unbuffed character. And in here, apparently we want to do something like character how are we calling this one? So we can have another function that initializes these things here. But the point was we were somehow calling the character in this way. Oh, so the point is, hold on. Name and ID, name and ID. Oh, and then there's name. Oh, gotcha. Okay, so it would have to have everything. So it would still have int health, int damage, buffs buff. But in this case, it's only going to initialize buff, but then it's going to call character with health and damage. Like this. And this is fine, it's just in a linker error because we don't have main. And so we'd think, hey, this constructor is going to initialize the member's health and damage with the parameters, the arguments passed to this function, or passed to the constructor when initializing and creating this variable, this object, this character. But then we have another constructor in case we want it to be a buffed character, and it will buff the character, and it will also call this other constructor. But apparently in doing so, it doesn't actually do that. Let's find out what it's actually doing. Okay, and we're going to create a character called Ethan, and I get 100 strength, or 100 health, 50 damage, and buffs. Oh, I can't pass that? Really? Why not? Oh, strength up is already here. So we could call it like this, or... Oh, I don't know why that wasn't working. Okay. And we give it a buff like this. And then, could just say outside here, like a friend function or something. And then I could have a print function here. We could have getters, so we could say, real quick, and we could just get the buff, but we could say, oh yeah, this gets the buff and we have to pass it to get buff as string. Okay, that's fine. So we could say 4 getters. One is an int get health, and it's const, return m health, int get damage, const, return m damage, and then finally buffs get buff, return m buff. Wait, what? Okay, and now we're gonna do Ethan dot get health, Ethan dot get damage, and get buff as string, Ethan dot get buff as active buff. Okay. Oh wait, hold on. Here it is. So we've called this constructor, and it is initializing the mBuff member with the buff value that we've passed to it. However, it is not initializing these parts. I'm assuming it's because when we call a constructor from another constructor, it doesn't do this pre-body initialization stuff. It isn't run. I think what it's doing is executing this body. And we can test this by just outputting attempted to first constructor. Sure, we'll just do that. And we can see that first constructor is called. It's just that M health and M damage are not initialized. So it seems like this part is basically just commented out. It's not being ran. So we'll figure out how to actually do it in a sec, I guess. It's probably good practice here to say health is 0, this is 0, and the buff is nothing. You know what? I don't like that. I'm leaving it value initialized. It's fine. Maybe later I find a practice I want that I like. Because I don't have a default enum that I want there, and I also don't want this to be a standard optional enum. Maybe it could be, but alright, so we have, alright, so we're creating an employee with called Dave, who's 42 years old, and it says true. So we're calling the employee's second constructor, which includes that bool is manager for the third, well, as the third data member, but the third constructor argument. So we'd think that it would initialize manager and then call the employee two parameter constructor, initialize those, and then we have a fully initialized employee. But it says employee Dave was created, and it's actually even printing M name. So it has access to the value here as the argument. Or actually, hold. This is actually the data member, and it looks like the data member has been initialized because it's being called Dave. So if this guy's been initialized for sure, but then this, it seems like it was initialized, but then also not. Because it says employee Dave, and that's okay. So it looks like this was initialized, but it wasn't stored, maybe? After E2, so this employee finished construction, still appears as the initial value, even though it was supposedly initialized here. Supposedly. You're expecting this call to call the constructor to initialize the rest, but it's finished once the member initializer list is finished executing, meaning once the constructor is initially called when we create the object, the member initializer list is finished, so it won't initialize anything else. Okay. That's a one-time thing. We can't just call a constructor again to keep initializing. When called from the body, the call to the constructor is actually, so each time we call a constructor, it's creating an object. So if we create another employee with name and ID, that other object is created. A whole separate object is created where this constructor is created, where it is indeed initializing mname with name and mid with ID. But after this returns, this is a temporary. When we look at this object, these guys are not initialized. Interesting. Temporary object. Okay. Temporary unnamed employee object. And the name is set to Dave and the age is whatever. And cool. And it is the one that prints employee Dave created. But then it's destroyed, so our actual permanent object doesn't ever get initialized how we want it. So do not call constructors from other function bodies. If we want a temporary object, we may as well just create the object itself. I.e., don't call the constructor. Seems like let the constructor be called automatically. Because it is called when we do our list initialization, like right here. Delegating constructors. To another constructor from the same class type, meaning inside the same definition. Constructor chaining, meaning that we have one constructor that does something with another constructor. It chains. Call the constructor in the member initializer list. Hold on. What the fuck is happening here? So we have an employee, it has two data members, a standard string, and an integer ID. Excuse me, we have a constructor that's called when it's only given a name and no ID. Excuse me. And in that case, if that happens, we want him to get an ID. So we're going to call, or I guess in our initialization, we're going to call the other constructor via delegate initialization. And we're going to say, hey, pass this value as the blank ID to this other constructor. And that constructor will actually do it. So, in the same sense, we should be able to do... I'm getting really, really sleepy. I need music. Oh god, such a great game. I need something good. I need something to make me go crazy. Nah. Come on. I hate this apartment. It's always a 5-second delay. Oh, that's the BPM I need. Alright, lock it in. Let's go. Alright. We need a character. We're gonna call him with health and some other shit, and then we're gonna call no buff, and then we're gonna have no buff as the default enum. Cool. Alright, let's go. Alright, hold on. Clear this off. Don't look through the glasses. Mousepad is a little screwy. Alright. Enum buffs. What are the options? Default one is no buff. Or we could say none. Or we could say no buffs. Strength up. Agility up. And we have a class character. And it has private data members. Hello? Oops. Int health. Int damage. And buffs buff. In public, it has a constructor, character, and it takes, in one instance, sorry, I fucking messed up the naming again. I'm getting there though. I'm realizing it earlier, I think. Int health, int damage. Okay, so here's one constructor. And in this case, it's actually going to call this other constructor that I'm going to make in a second here. So we're going to make, first I'm going to make this other constructor, I think. We're going to make character, and it's going to take an int health, int damage, buffs buff. And what it's going to do is say m health gets health, m damage gets damage, and m buff gets buff. Cool. I don't like all the errors before it finally is okay. And now we're gonna have another one that only takes int health and int damage and no buff. And what it's gonna do is it's actually gonna call character with int health, int damage. Oh, actually it's gonna say, it's gonna call it with health, damage, and buffs. Well, I may as well, do I care? I may as well make this enum class, right? And it's gonna be buffs, no buffs. And then, boom. Cool. Delegate construction to 3 parameter constructor for no buffs. In case buffs aren't, or in case buff isn't specified, or no buff. Constructor that constructs the object. And then we can have our getter. Okay, and we're gonna have int get health, const return health, oops, m health, int get damage, const return m damage, buffs get buff, return buff, m buff. And then we could also have a friend function called and this is a standard string view, get buff as string, and it takes a buff, using buffs, or enum buffs, switch on buff, case no buffs, or case no buffs, because now we're using it, so we can say this, return no buffs, no buffs. Case strength up, turn strength up, case agility up, return agility up, default, turn none. And now I can create a character called Ethan, and I get 100 health and 50 damage and no buffs. Character without buffs. Ethan has Ethan.health, health, Ethan.getDamage, damage, and get buff as string Ethernet get buff. Hold. There we go. And now we have no buffs, even though we didn't specify it. And the reason is because in the constructor, we're actually delegating construction to another constructor. It's kind of like having overloads that are disallowed. So instead of saying, hey, we have this version and I only want you to call this version, so I'm actually gonna not allow you to do this one and not allow you to do this one. Or if you call it in this way, I'm gonna handle it and it's actually gonna call this one. And if you call it this way, which I don't want, it's actually gonna call this way, or it's gonna convert and then call this way. Something like that to remove any implicit conversions. So, or you could just delete, only call it this way. But in this case, we're saying, hey, you can try and create it this way or this way. But if you try and create it this shitty way, we're actually going to redirect you to create it the other way with the proper values. Oh, you created it without a buff? Well, I'm going to call it with no buff. I'm going to call it with the values. So we're going to say we're actually going to call this guy with health, damage, and no buffs. And we could have done one more thing here. This can be const expression, because we're not outputting anything. Everything here can be done without runtime at compile time, allegedly. So we're delegating initialization. We're saying, hey, use 0 for the ID. We have to use the ID. Like maybe you have a character constructor and you have a bool is dead, and by default you don't want the character to be is dead, because if you create a character it shouldn't be dead by default. Maybe you want to spawn it dead, so then you have to pass in true for is dead, or false for is alive, something like that. But when you call it, maybe by default, if you omit the is dead, you could do a default argument, sure, or you could do two constructors via constructor delegation, and you call the one that includes is dead, and you call it with false. Because by default, it's not dead. So if you call him to create James and you don't specify he's dead, well, he's not dead. Okay. The member initialize a list, delegates initialization to the other constructor. How exactly that works? No idea. A go to or something? I'm only now realizing the harmony in this song. It's really strong. The value of name James is passed as the argument, and then 0 is the second. Yep. And the member init list of the delegated is the one that initializes. So basically, during initialization, it's actually calling this object and then not doing. Interesting. So if we call a constructor explicitly, we're creating another object. If we instead call it with the braces, we're calling the constructor here for this object. We're calling it here for this object. Interesting. So we could say excuse me. Yeah, so first we call here. We're basically, I guess we're calling this constructor with this syntax because it's the same as here. We're just not naming him. And it applies to this object, which we're calling. So now we're calling this guy, initialize the values, say that we've initialized the values, and then we come back and then do this body. We could do A and then B. What would happen is it would actually call B, and then it would say A. And the point is we're delegating the initialization to the other constructor. And the point here is that the value is going in here twice, meaning that there's a parameter and then there's another parameter to initialize this parameter. So if we don't pass the value, we save it the value. I don't see an issue with that right now. Yeah, it would make sense because if I had the one with more parameters, why would I go to the one with less? Yeah, I mean, it wouldn't be able to, there'd be nothing to pass. It wouldn't be able to pass the ID. One constructor can delegate to another constructor to delegate an infinite loop. Yeah, that makes sense. Yeah, why would you do that? Yeah, and I would agree with this. This is exactly what I said earlier. What are we preferring? Okay. Default values can be used. Need another song? No, no, no. No. Okay, let me warm up for push-ups real quick. Okay. Yeah, so we could have one constructor, and we could say, hey, instead of having a constructor that passes basically a default argument to another one if it's omitted, why not just say that if it's omitted, it uses the default argument? This seems like the same way, but it's more succinct. One function. Unless in that case we want to handle something only in that case. Because here, there's no way to check, there's no way to know in this call whether ID was provided a value or not. The reason why is because we could pass in 0. So checking if it's 0 does not work. We'd have to have another constructor, which this one would return, and then the other one, well, this one would evaluate, and then the other one would evaluate. Excuse me. Which maybe that's helpful for some reason. Like, what would be a case there? I don't know, it's fine. Oh, gotcha, because you have to order them in the right way. So now that we have to use, now that default arguments have to be on the right side of the function, we may as well order it so that that argument is also the last data member. Because that's the order they'll be initialized anyway. Makes sense. Yeah, which one do we want? Do we want default values? Well, I don't know about them being default yet, or redundant yet for default. Members for which the user must provide initialization values. Oh yeah, it was the same thing as it just said. Yes, the default, the parameters with default arguments must be to the right, which means those data members must be after. Bro, where is this? Holy shit, dude, it never plays. This is like a copy and paste, hello? Also requires duplication of the default initializer, meaning that if you put 0 up there, well, yeah, but I'm not putting that there. I'm just putting value. Hello? It's an int. I mean, wouldn't we do arguments? Isn't that the best play? Oh, we don't even say the best practice? Are you kidding me? Oh, here it is. Agreed. This song is too much of a banger. The push-ups are happening now. Oh my goodness. These are crazy good. These voices are in just great. Let me warm up a little more. Wow, I'm actually getting stronger. Holy shit, I've never done a clap push-up before. Oh, this is gonna fucking hurt. Oh, fuck. I need to stay straight. Better. I'm gonna do. That's it for now. I'm gonna do a little more later. Oh. Okay. Yeah, so we don't have literally the same member initializer list in both. Are we? That's the point. Yeah, it's like a triad. So there's the default initializers up here, and then there's constructor. This constructor says, hey, if this little piece is missing, delegate to this guy, but use this value. It doesn't have and it has to be given this value literally. It doesn't have the ability to say, you use this value, the default value. So if we do constructor here and it explicitly initializes shit, and then this one explicitly initializes shit with a different amount of parameters, and then if they don't specify stuff, hold on. Well, if they don't specify, then it's not gonna work. It won't work. The constructor won't work. If it's an empty constructor, then it would. Hold on. Yeah, if we're delegating. Right? I'm pretty sure if we have a constructor that's not default, then we can't use the default initializers. There's no way to specify that a delegating constructor or default argument should use the default member initializer. When we have an initialization value used in multiple places as a default member initializer and a default argument, so we have a default argument here, but we also... Oh! So we can only do that with static, really? So instead of having 0 be here and 0 be here, we could just make it default, or make it static and const expression, and reference it here. But if it's not const expression, then I don't think we can do that. So what would be the issue here? I'll hold. Hold on, just doesn't have another constructor yet. Wait, isn't this fun? Couldn't we do this? Or we could just do... Uh-oh, hold. For a default parameter, we have to use it like that. Interesting. So if it's used... Yeah, but it was okay here, right? So what if we do... I'm gonna do funky numbers. Oh. Oh. Hmm. What's happening here? Hold. Oh, oops, sorry. So it was fine here. Oh shit, hold. Ah. Wait, if we're doing that, then... Then why would we even provide it? Would we not? We wouldn't. So this isn't one that we provide because we can't initialize it. It can't, it's const, yo. And so we use it in a way that we don't have to specify it? What's the point of that? I don't understand right now. Alright. When we have an initialization value used in multiple places, a default member initializer and a default argument. Find a named constant and use it wherever. Excuse me. What would be the purpose of that? Just to use a default initializer in the constructors so that we don't have to duplicate it? Oh, that was the point. It's a default argument. So we would be... Oh, well, in this case... We don't use it twice here. We need this to be int m current rounds. Okay. And this is the point. When we call this, here it is. Hold. There it is. I understand now. I was giving up for a second. It's because this guy is second. These are the main ones. These are the ones that we can initialize both of. I can do 30 and 25. And we have an AK that has max 30 rounds in a magazine, and currently it has 25 when we spawned it in. Or we could use the default value. Well, what is the default value? It's actually a static constant that we've made. Because if I just put in 17 here, there's no way. Let's see. What if we just didn't do that? Hold, what's the issue here? Oh, what if we just didn't? Huh? So 17 works here. Or if we pass it nothing, then this value is already used. But if we pass both, then we can override it. So we could say 30, 20. Why would we want that? If we specify 2, then we're specifying it. If we're not specifying it, then we can do it. I think these are a bunch of different ways to do the same shit, really. I think that's what's happening. So if we use an initialization value in both places, like here, we could just leave this guy. Oh, and we can also default him here too. So we can do it a bunch of places. We could create a constant and leave it here. Or just leave it with the default value and not initialize it here because it's default. Or, and if we have a second constructor, we could just not specify it there. Or we could have this and leave it be a default argument here and have this be in both places. Which is basically the same thing. And then we have this guy once here and then there. Yeah, this. So when we have a value that's used in multiple places, we can define a named constant and use it wherever the value is needed. That may it's defined in one place and not multiple. Okay. Why static? Don't know yet. Apparently it's an overloaded term for classes and means something different. So we have a name, we have the ID, and it is by default 0 instead of just putting 0 here. And the point is so that it's defined in one spot. It's defined here, and it can be changed, and it changes here, and it changes here, and it changes anywhere else. And then in the constructor, we say, hey, if you pass me a name, I got a name. If you don't pass me an ID, we use the default ID. But if you do pass me an ID, then we can do this. That way we're not saying this is, well, we could just pass the default value here and then leave it as is here. And then it's done. I guess you can still go either way. There are multiple ways of doing this. Right? Isn't that correct? We could say we don't need this at all. Current rounds is defined, and we could say, hey, if you specify one value, we've got this, and current rounds is default. And if we, let's see, that's 1. And if you call the other constructor, well, we don't need a default argument here because then that's just this, and that would be an ambiguous call. But we could say, you call gun with 2 arguments. This guy could just be equals m current rounds. And then we could say, oh, here we go. Maybe it does need to be static. Wait, hold. Okay, so sometimes the syntax is func. All right, just noted. Sometimes it wants you to use a static member for a default argument. It doesn't want you to default it to what the defaulting already is if it's being specified. Because if it's specified, it's not going to use the default value. I think that's how that works. For specifying it in the default value 17 here, I can't just say this equals the 17. I have to have it somewhere else to look at because I think this somehow gets wiped. Use of static lets us have a single default ID that is shared by all employee objects. Without static, I'm not sure what it would be yet. Without static, each would have its own. So instead, if we have it static, it's shared among all. So if it somehow changed, it would be the same among all. Oh, gotcha. And the point of static is to make it so that there's one. It's like being inline. So there's only one copy in the entire program. Downside is that with each additional name constant, you have another name. Okay. Write a class named ball that has 2 private members, 4 constructors. Goddamn. So it has nothing. It has blue as a number, and it has blue and 20, and it has the default color of black and the default radius of 10. Okie dokie. Okay. So we have class. Well, let's just get int main to remove those linker errors. Class ball. And we're going to do include string because we need standard string. Private. One thing that's private is a standard string called color. And another is an integer called, or a double called radius. And then we have public constructors, ball, and it takes a few things. 1, it takes nothing. And then another takes, oops, these need to be named better, m radius, m color. 1 that takes a standard string reference color. 1 that takes a double radius. And another that takes a standard string reference color and a double radius. And if we have nothing, what we're going to do is pass in. So we have different constructors here, so we don't have default arguments. We could just do this with 1 fucking constructor. 2 default arguments. Black and 10. You put nothing, it's black and 10. You put red and nothing, it's red and 10. You put nothing and 20, it's black and 10. You put purple and 24, it's purple and 24. one thing, 2 default arguments, much better. But in this case, we're going to call... Do each of these just call the final one? Because if this one calls the next one... If we say this one then calls this one with default black, oh, there's no way. I mean, I can't do I mean, we could do some const stuff, but I guess it would want static because it was complaining about static earlier. So one way would be to call it with 2 things. Let's see. So we could call it with nothing. So this could just call ball with black and 10.0. This needs to be a const standard string reference because that's an R value. Well, it's an L value, but it's a const L value. That's the problem. And then we could have another that calls ball, in this case with color, and then with 10.0. And then we could have another one that calls ball with, calls color 10.0. And another that calls with black and radius, and another that initializes m color with color and m radius with radius. Okay, so each of these is calling the master constructor just in case. So this is the main guy. And we could just put in default argument 10, default argument black, default argument 10, call it a day. But instead we've made 3 other fucking constructors because we're retarded. And each one of these will call with the appropriate ones. We could have another thing that's a const, or maybe a static const standard string called default color, called m default color black. And we could just pass it m default color, and it seems like it's maybe happy with it. Hold, why is it not yet? Oh, what? What is it complaining about? Oh, fuck me. Cannot have an in-class initializer? What are you saying? This is a const standard string. Okay, what about here? Okay, so if it's not static, now we're cool. It just doesn't like being static. I don't know what static is doing to it. And so, okay. I'm not really sure, honestly. So I'm going to just remove static. And now we're going to make black be this m default color. So it's defined somewhere. And this can be m default color as well. Ow! And then we could also have a const expression int. And I guess we would have it be static. Well, and the problem here is that each instance of this class would have a separate standard string because it can't be made static. What if we made a const static standard string? Hold. Yeah, it's still not happy. It doesn't care. Static const expression int default radius 10.0. Oh, sorry. This needs to be a double. And then this is going to be, we would just pass it this is m default radius, m default radius, m default radius. Okay, so we could pass it nothing. We could pass it the color we received in default radius. We could pass it the default color and the radius we received, and then we could just pass it color and radius. Okay, and then we could say our getters. We have a const standard string reference get color const return color, and then int get double get radius const return radius, and then we could make a ball, my ball, and then we could have a function that prints the ball. So we could just have void print ball, and it takes a const ball reference ball, and what it does is it outputs, oops, we don't yet have IOStream. And it prints ball. You know, I'm gonna just make a static int ball ID 0. And then we're gonna say ball ID color ball dot get color, radius ball dot get radius. All right, we're gonna do my ball. We're gonna just say ball one dot, or we'll print ball one, and then we're gonna do the same shit here. 4 4 3 3 2 2. Boom. Oops, I didn't increment this. Ball ID. All right, and let's just do this first, sure. Ball 1 is black, radius is 10. Ball 2 is, hold. Oh, I didn't pass it any different arguments. So now we're gonna do, in this case, blue, or hold. We're gonna do the second one, we're passing it blue. The second one, we're passing it, hold. Oh, the second one we're passing it 100.0. That is weird. It's not like a default argument. I can just pass this, and the first guy can be blank. I don't even have to worry about this being the wrong call. Okay, that's interesting. And then now we could do purple 20. So with nothing we get black and 10. With 2 we get blue and 10 because blue is the default value. With 3 we get black because that's the default color, and then 100, and then we get purple and 20. Okay, interesting. Use a const, cool. Constant string. Okay. All right. Well, that works. And in this case, he's probably hard coding the values. Let's see, hold. All right, class ball. We have black and then radius. It's default black and radius. If it's nothing, at what? What? Bro, what the fuck? Why are we printing in the constructor, bro? No. But the point is we're calling it. And so we could have each of these calling the final guy, or we could just have each one not touching the default values. Isn't that the point that I made earlier, that we didn't have to do it this crazy way? Or we could just say ball. What does ball do? Ball doesn't do shit. But then we have ball that takes what the fuck is happening here? Oh, because this the lines are being combined and fucked up. Okay. In this one, it takes a color. A standard string color. What does it do? It says m radius. Oh, it says m color is color. And then we have another that takes an int radius. What does it do? It makes m radius radius. And then ball standard, oh, this needs to be a const standard string reference. Standard string const standard string reference color int radius. And in this case, m color is color and m radius is radius. Is it this fucking hard? Hold. I totally said int. This needs to be double, as does this. And the results are the same. So you could just say, hey, initialize the other shit. Or you could have each one of them call this with the same bullshit, which I don't like. That's why using the default arguments is, or using the default initializer is fine. It's just that when we're the thing here is that this isn't, we're not delegating. Oh, wait, hold. Excuse me. No, we're not. No. Yeah, this is not delegating. So when we're delegating and we're using it in multiple spots, maybe we want a default one and blah, blah, blah. But in this case, we don't even need to delegate. We could just, or to delegate, we could just have a default constructor like that. Or maybe even better yet, we just have one ball call with a const standard string reference. Oops, hold. I think the default arguments aren't going to be happy here. We're going to just say is black and double. Oh, it's not named. Color is black, so it wanted a color. It probably said expected identifier. And then double radius. M color is color. M radius radius. Hold. And it doesn't have a default argument. 10.0. Hold on, 37 is having an issue. Oh, that's the problem there. Okay. So if we do it that way and we're not specifying black, then we need to accept it as is and do some delegation or have a separate constructor set up. So in this case, we could just remove this, and then do this, and then leave it as the default value, or do the other thing. So we can handle them separately, or we could delegate. Those are the answers there. Otherwise, the default argument will kind of screw us up. Yeah, that'll work. Yeah, that'll work. Cool. And then reduce the number of constructors. Oh, there it is. By using default arguments and delegating constructors. Okay. So I could do delegating constructors. What's the smallest number of constructors we could get? Ball. Okay. So what do we want? We want the smallest possible. If we do a default argument, we can't do a default for the left and the right guy. I mean, we could still have 4 constructors that way. Oh, I guess we could just do 2, huh? So we could have one that's everything, that takes a const standard string reference, color, and a double radius, and does its thing. M color is color. Oops. M radius is radius. And then ball up here, if it only takes, let's see, hold. And in this case, we could say double radius. Well, we don't even need that. Oh, we still want to accept it though. So double radius is, I don't think it's going to like M radius here. Oh, okay, so far that was okay. Uh-oh, here it comes. Here it comes. It needs static on 16. Yep, alright, so it's not happy. It would want another thing, but alright. In this case, I'm just going to put in 10.0, which is fine for now. And it's going to remove that big error. And the problem is that we can't use a data member itself as a default argument. But then here, we just need to handle... So if they passed in color, now we need to pass in if they don't have color. And so we could do double radius is 10. And then... Or, oh, sorry, we don't even need to do that. Well, this could be nothing. If they pass in only double radius. If they pass in nothing, then it's 10. And then we call ball with black and radius. And it handles all 4 cases. 2 constructors this time. So if they give us nothing, all right, and in this case, it's going to be complaining if I do M radius. So what we would need here is const expression double default M default radius. Well, it shouldn't even be a data member, really, I don't think. Double default radius 10.0. This is now default radius. This is now default radius. What is happening here? What the fuck is happening here? Oh, can a double not be const expression? Oh, static. Oh! Oh. Hold. Uh-oh. Hold. Oh. I need a semicolon. That makes sense, because otherwise it was thinking we were doing a const expression string. No, sir. Can't be. Can't be. That doesn't work. So, and the default argument here is default radius. And then we could just have color be as is. But then if they omit color, this is passing the default color. So we may as well want... default color too, right? Maybe? Const standard string, well, or we just leave it. Well, that's because it's the literal here. So what if we said const standard string default color black, default color, default color. I fucking forgot the semicolon again. And so we're saying, hey, you call this guy with nothing. Okay. Or hold on. You call him with nothing. Then we're going to pass in default color, and we're going to make radius be default. And then we're going to call this guy with both. And then you're going to initialize these guys to be those default values. You could call them with radius alone, which means we're going to still pass in that, and then we're passing in default color, which you're going to initialize. We could also pass in color alone, which means that color gets color and then radius is default. Or we could pass in color and radius, and all those get handled alike. Is there a way of doing one? If we do one constructor, then we need to be able to handle 4 things. No inputs, color only, radius only, color and radius. Well, we could handle nothing, and we could handle color as a default argument and pass in radius, or we could handle no color with radius as a default argument, and then call the second constructor. So we can't do one. I think this is the best bet. So if we do one constructor, we can handle nothing, and we can handle one default argument, and then we pass the default arguments, or well, the default values, or a default value and a default argument. And then on the other side, if we do one, we can have the other guy be a default argument. So in the first one, we have radius be, oh wait, hold on. Why are we... Hold on. So in the first, we handle nothing. If we handle nothing, we give it default color and default radius. Excuse me. So we handle nothing, and we handle radius alone. And then we handle color alone, because this is default. And then we handle both. I think this is the strat. I think this way works. Yes! Oh, so we could handle... Wait, what? How is he doing two? How is he doing two? What? Hold on. How is he doing it? So he's saying to handle ball with nothing. How is he doing standard string view color black and color radius as two default argument? Wait, hold on. Oh, I think it's just how he's organized it. So in my case, we can call it with nothing. No, he still has delegation. So mine handles two cases and two cases. This handles when both are in here, and when only color's here. This one handles when none are in here, or when radius is here. And then his handles radius specifically, but then this other one handles nothing. So you can do multiple. What was the problem with multiple earlier? It was that if we omit everything, it's boom boom. It does both. The problem was that if I can't do only the rightmost one, which means we have to create another constructor with the rightmost one. I don't like his way of doing it, honestly. I like mine more. And then, cool. Yeah, his just feels kind of funk. You can do different ways. I like mine. I think mine makes most sense. Because he just makes another thing to handle another case. Mine handles half and half from the get-go. Okay, no, not games, motherfucker. Bro, stop bookmarking here, you cunt. What is happening? Alright, we're good? Okay. I hate bookmarks. Alright. I love them. I don't know what I'm saying. I'm just hungry or something. I'm just being a wimp right now. I'm just being a weak human. Alright, cool. More self-test later and learning.